Let's start off our exploration into gravity with this interesting problem. We're given a mass, capital M, is split up in two parts, a little m, and then there's m minus m. And it's separated by a certain distance, and it would be a specific distance that's not changing. We've got this m and an m minus m over here. Okay, and then we're asked what ratio of m divided by m is going to give us the maximum gravitational force, the maximum magnitude between these two parts. All we have to do is think about what our equation of the force of gravity is, and it's g m1 m2 over r squared. We're asked how to maximize the gravitational force. That's this. How do you maximize things? How do you find minimums and maximums? Remember, we have to take the derivative and then set that equal to 0. So if we could figure out what the derivative of f is, and we set that equal to 0, that'll give us a minimum and maximum. But the question is, what do we take the derivative with respect to what? What do we put over here? df over dy? Is it dx? Is it dt? Well, let's think about it. Because there's no x, there's no time. And is it r? Is it r that's changing? No, r's not changing. We're not changing the distance. Is it m1 or m2 that's changing? I mean, maybe it's m1 or m2. We don't know which m it is, I guess. And then there's also this g. Is g changing? No, g can't change. So this g is not changing and r is not changing. We gotta figure out, it's gotta be one of the m's, right? And if I just look at this, and it's like, it seems to me that one of the reasons why we would choose little m is that it's a common variable. Common variable, right, between these two terms. That's the thing that's going to change. And then all of a sudden, when we change those things, dm, and then we got the df on top, that'll give us how we can sort of get this setup going. I think it's going to work. So df over dm, and we're going to go g, and then, well, the first mass is m, and then the second one is m minus m, and then it's r squared. And if we need to rewrite this a little bit, because we know these two are constant, right? So let's just put them on the side over here. And then we're going to be messing around with this stuff in the middle. m minus m squared, okay? And we're still taking the derivative of this. If we can try to, I'll even just put that right there. Now, let's just go ahead and rewrite this over here. On the inside, we know that the m is actually a constant, so really it's just the m's that they're like variables. Okay, if we had an mx minus x squared, you know, how could we do this? It would just be, I'll make it even easier, 4x minus x squared. How could you take the derivative of that? It would just be 4 minus 2x, right? So obviously it's just m minus 2x, isn't it? So m minus 2x is the derivative. No, not x, that's m. Okay, m minus 2m. And now we're good. So we just need to set this equal to 0. And then that'll give us basically the maximum or the minimum. Well, really it's the maximum, I guess. Okay, and we're just gonna see what happens. Okay, so we go m. We could divide g r squared on both sides, and then it would just be m minus 2m equals 0. M equals 2m, and we'll divide m on both sides. We'll get 1 equals 2m over m, and then we'll divide the 2 back over there, and we'll get 1/2 equals m over m. All right, simple stuff here, but that's basically our answer, and that's gonna give us the maximum gravitational force when that's equal to, the derivative is equal to 0. Okay, so yeah, that was kind of interesting. We just have to figure out this part right here is the most important, because you're asking yourself, this will change, the force will change if this changes right here. dm. So the force will change if the mass changes, and that's why we kind of set it up like that. It's a little bit difficult to kind of set these equations up.